Okay, limiting and excess reactants. Okay, so by looking at these terminologies, limiting and excess, you can easily understand their meanings. Limiting reactant is a reactant that limits a chemical reaction. And excess reactant is the one that is present in excess quantity, and it does not limit the chemical reaction. Okay, so limiting reactant will always limit the chemical reaction. How is that possible? Take a very common example for, let's say, if you have, sorry. Okay, let's say if you're making sandwiches, okay? These are the slices of bread maybe, okay? So you've got 8 slices of bread and you have 3 patties for the sandwiches, okay? How many sandwiches will you be able to make with these 8 bread slices and 3 patties? Complete sandwiches?
3 sandwiches.
3 sandwiches, right? You won't be able to make 4 of these. Although, yes, you do have enough bread for 4 sandwiches, but you won't be able to make the last one. Why? Because you don't have enough patties. So, which of these breads or patties is the limiting reactant?
The fourth one.
I mean, no. Are you restricted because of the bread or because of the patty?
Bread.
No, bread.
No, I mean the patties.
You have enough bread.
They're limiting.
Exactly. You can make another sandwich if you look at the breads, but once you look at the patties, you cannot make another sandwich, right? So this is the limiting reactant here. Your chemical reaction has been limited. You cannot produce more product. Why? Because you don't have enough reactant. So think of bread and this patty as your reactant and the sandwich as the final product. You've got a lot of bread, you've got 8 slices of bread and 2 slices per sandwich. So you can definitely make you can definitely make 4 sandwiches if you have 8 slices of bread. But if you have, let's say, 3 patties, you cannot make the 4th sandwich because you need 1 patty per sandwich. Okay. So this is exactly what a concept of limiting reactant is. Any reactant that limits a chemical reaction is a limiting reactant. Now let's look at chemistry here. For example, if I write this equation down, NaOH plus HCl producing NaCl plus water, this is a neutralization reaction of acid and a base. If you have got, let's say, 50 grams of sodium hydroxide and 100 grams of HCl, so can you tell me which one is greater here? Do you have more sodium hydroxide or do you have more hydrochloric acid?
Hydrochloric acid.
Have more hydrochloric acid. So hydrochloric acid in this case is the bread and sodium hydroxide in this case is the patty. So which one is the limiting reactant?
NaOH.
Why? Because the quantity of NaOH is lesser and your reaction would also be limited. Your reaction will proceed according to the quantity of NaOH. Even if you have 100 grams of, you have 50 extra grams of HCl, but still, as your sodium hydroxide will get finished, as this 50 grams will get completely consumed, your reaction would stop there. Let's write down this definition now. That a limiting reactant is a reactant that limits a chemical reaction. And the other reactant is known as the excess reactant. Now, how to measure that limiting reactant? I mean, you can maybe look at the masses, you can look at the moles, the volumes. So any physical quantity will tell you about the limiting reactant. In the case of sandwiches, we looked at the quantity, the number of patties, right? So that was the physical quantity over there. But in the case of I mean, the chemical reactants, you won't be looking at their numbers. Okay, you have, let's say, 10 bottles of hydrogen, you have 10 bottles of sodium hydroxide. No, you'll be looking at their exact masses or their exact moles or their exact volumes, because that is how we make appropriate chemical calculations, right? So limiting reactants will, I mean, in order to know which reactant is a limiting reactant, you need to understand, you need to know their moles and their masses and their volumes. Okay. So for example, again, if you look at the same equation again, you have NaOH reacting with HCl, producing H2O plus NaCl, and NaOH is again 50 grams, but now you're given with, let's say, the volume of HCl 500 cm cube, and you're given with the concentration of HCl, that's 1.2 moles per dm cube, and you're asked to tell which one is the limiting reactant. Now, if you look at this question, you're given with the mass of NaOH, but you're given with volume and concentration of HCl. In order to make a comparison, you will either need masses of both of these compounds, or you'll need volume of both of these reactants, right? So what is the best way? Can we, I mean, can we make a genuine comparison between the mass and the volume here? No, we cannot, because we need the same physical quantity, right? So what we need to do here is we need to figure out mass of HCl as well. Can we figure out the mass by looking at these two physical quantities?
No.
No. Can we figure out any other physical quantity once we have volume and
We
concentration?
can, yes, we can we can check the concentration. No, we already did. Moles.
Moles. Yes, we can figure out moles, because the formula is concentration is equal to moles over volume. So concentration is 1.2, moles is X, volume is 500. We need to convert it into dm cube as well. So dm cube, in order to convert cm cube into dm cube, you need to divide the quantity by 1000. Okay. So you're gonna get 0.5. All right. So you need these conversions. Cm cube must be converted into dm cube for volumes. So 0.5 into 1.2, can you use a calculator?
0.6.
0.6. So now, this is the moles of HCl. But again, we cannot make a comparison between mass of NaOH and moles of HCl. Either we need moles of both of these quantities or mass of both of these quantities. So can we maybe figure out moles of NaOH by this mass? Yeah, mass over MR.
Yes, we can.
X moles, mass is 50, MR is what? Sodium is 23, oxygen is 16, hydrogen is 1. 39, 40. Its MR should be 40. Could you maybe check? Yes, it is 40. So 50 over 40 is 1.25. So the moles of NaOH are 1.25. Now we know the moles of both of these reactants, 1.25 and 0.6. So by looking at the moles, which one do you think is the limiting reactant?
HCl.
HCl is the limiting reactant, absolutely, because the moles are less. So this is how you make the comparisons. Though I hope this is clear. First of all, you need to have both of the physical quantities in the same units, either moles, either masses, either volumes. Okay. If you have different physical quantities, use these formulas and convert them into a single quantity. Okay. It's always preferable to go for the moles. Okay. Convert everything into moles and then see which reactant has lesser moles. That reactant would be the limiting reactant. Now, if you're clear, we can move on. So step 1 is to convert the quantity to moles and then compare them. And step 2 is to compare the ratios. Let's say if both of the quantities are already in moles, so obviously the lesser one is Okay, sorry, let me just explain it to you here as well. NaOH again plus HCl, NaCl plus H2O. Focus on the coefficients. NaCl, sorry, NaOH coefficient was 1 here, right? HCl is also 1. Everything is 1 here because the equation is perfectly balanced. So when the coefficients are 1, the answers, the moles that you get in this step, these moles are enough for the comparisons, okay? But let's say if the coefficients here are not 1, so you will have to perform an additional step. If coefficients of the reactants are not 1, perform an additional step. And that additional step is to divide moles over coefficient and then make the comparison. For example, I'll just explain that to you. Let's say if it was 2 NaOH plus 3 HCl, just an example, okay? And X or Y, any other product. So in that case, your moles of NaOH were 1.25, right? And HCl were 0.6. In the previous step, what you did was you made a comparison here, right? You said that 1.25 was greater and zero point 0.6 was lesser. So definitely HCl was the limiting reactant. But in this, but now since you have the coefficients as any other number other than 1, 2 or 3, what you're going to do is you're going to divide these with the coefficients. 1.25 over 2 and 0.6 by 3. Can you tell me the answers for these divisions? What is 1.25 over 2?
We will use this method if the coefficient is not the same.
Yes, definitely. If the coefficient is not the same, yeah. Or if it's not 1, I mean, if it's even same, or let's say 2 or 2, 3 or 3, you'll still perform this step. You will only avoid this step if the coefficients are 1 and 1. Okay, what?
For NaOH, it's 0.62.
Okay.
And for HCl, it's 0.2.
Okay. So which one is lesser now?
HCl.
HCl. So this is your limiting reactant. So I hope this is clear now. In the first case, you were to make comparisons right after you had figured out the moles, because in that case, the coefficients are 1, 1, 1. But in the second case, when the coefficients were not 1 and 1, what we did was we divided the moles with the coefficients to get these two values, and then we made the comparisons and declared a limiting reactant.
Are we supposed to balance it on our own, or या फिर क्वेश्चन में हमें बताया होगा किसको बैलेंस करना है
I mean,
पूरे रिएक्शन को?
Question may, if let's say you're given with an equation in the question, generally the equations are balanced. But let's say if you're making your own equation and that's a part of the question or your answer solution, in that scenario, you will have to balance that equation yourself. Okay, this is why balancing is so important, because that balancing would directly affect the value of moles. Okay.
So like if it's not given in the question, like it's not balanced, then I don't have to balance it.
I mean, if the equation is already written as part of the question, that is, I mean, it is already balanced, even if there is no coefficient. For example, if you look at this equation is perfectly balanced. 1 and 1 are all the coefficients. I just added this 2 and 3 just to explain it to you. They can never be 2 and 3 with HCl and NaOH because that is against the law. Okay. So this equation is perfectly balanced. Okay. So I just hope you're getting the concepts.
Yes.
All right. Now, another part, okay, we're done with limiting and excess reactants, by the way. Another part of topic is Reducing stoichiometry by titration. So titration, what do you understand by this word titration?
Titration.
Have you performed a practical experiment of titration?
Yes, I think so.
Hannah, you're about to take your AS level exams in October, right? So you would have
Yes.
obviously done the practicals as well.
Yes, practicals that you did.
Yeah. So you must have done these titrations. Titrations are basically acid and base experiments. When you react an acid with a base and then you figure out the neutralization point, okay? The example that I just wrote, NaOH and HCl, that is also a titration equation where NaOH was the base and HCl was the acid, okay? So by reducing stoichiometry by titration is basically how you balance a chemical equation with the help of these titration experiments. You figure out the unknown moles by using titration, okay? So let's say if a question says that you're given, I'm writing down an example question and then I'm going to explain this concept to you with the help of that. So question is that 25 cm cube of 0.5 moles per dm cube of, let's say, acid is titrated against 0.2 moles per dm cube and 12.5 cm cube of HCl. Deduce stoichiometry of this reaction. Okay. So now in this case, let's say if I'm going to also give a name to this acid. Let's say this acid is magnesium, sorry, magnesium hydroxide. Okay. Sorry. No, that's a base. Isko change kar dete hain. This is HCl. Yeah, we can use HCl here. And this base, let's say, अच्छा यहाँ पे मैंने HCl use कर लिया है. This is, let's say, magnesium hydroxide. Okay, so we've given the name, so we could easily make an equation. So the question is trying to tell you that you need to make an equation of MgCl2 and HCl and even balance it up. How to do that, how to get the coefficients and everything, you're going to use moles here. Look at the data that is given. First of all, for the HCl, देखो, in a very useful trick to attempt these questions is to write the data down. Okay, HCl, what do we have for HCl? 25 cm cube. This is the volume, right? So the volume of HCl is 25 cm cube. Can we convert it into dm cube?
Yes.
By dividing it with 1000. 1, 2, 3. 0 will move 3 places back. 0.025 dm cube. So now we have volume of HCl as 0.025 dm cube. And the concentration, this is the concentration, is 0.5 moles per dm cube. Concentration is also given, 0.5 moles per dm cube. Okay, let's look at the data for MgCl2. 0.2 moles per dm cube, you're given the concentration and you're also given with volume. So given with everything here. Let's write this down as well. So for MgCl2, sorry, MgOH hona chahiye tha isko, MgOH hold twice. MgOH hold twice. The volume is 12.5. So we need to convert the cm cube into dm cube again, dividing by 1000. 1, 2, 3. 0.0125 dm cube. Okay. And you also given with the concentration. The concentration is, what was it? It was 0.2 moles per dm cube. All right. So we've written all the data down. Now, the next step is to use this data to figure out the ratios. Can we also write down an equation, first of all, an example equation?
Yes.
HCl plus magnesium hydroxide, neutralization, an acid-base reaction will always produce a salt and water. You would have done this in your O-levels chemistry. So
Yes.
salt and water, what is the salt? Magnesium, the metal basically reacts with the chloride. So MgCl2 plus H2O. You can go over your O-levels notes to revise these concepts if you want. I can even explain these again, metal and acid-based reactions, okay? So, okay, now this is an example equation, but it's not balanced. Now what we need to do is we need to figure out the moles of HCl and MgOH whole twice. We are given with the volume and concentration of both of these. So can we use these to figure out the moles here?
Yes, we can.
Concentration is moles over volume.
Yes. But won't we need to balance the equation first?
No, this is what the question is asking you to do. To balance the equation with the help of the moles. Okay?
Oh,
You don't have to do it on your own, first of all. Because why? Because in the real question, you might not be given with the identity. They might tell you that you don't know the name of this metal here. They might just tell you that you have a metal hydroxide. So up when the question just says that you have metal hydroxide, you don't know the moles, the MR, anything of that. Na? So you will have to rely on these calculations for balancing. So this is why, I mean, in the real question, you won't be given with one of the identities of the reactants. Okay, so now again, we're going to use this formula for both of these NaOH as well, sorry, MgOH as well as HCl to figure out the moles. Concentration for the first one is 0.5 and moles are X, volume is 0.025. You can use the calculator to find out the value for X. And then same goes for HCl as well. 0.2 is the concentration, X moles, and 0.0125 is the volume. Can you tell me the answers?
I can't see the screen.
Now, can you see it? Yeah.
Yes, I can. For the first one, it's 0.0125.
Mm.
And for the second one, it's 5 into 10 minus power 3.
Are you sure? Because this answer should be 2.5 or 5.
Let me calculate again.
Because once you multiply 0.0125 with 2, you're going to get 2.5 times 10 to the power minus 3 or 0.025. Yeah.
Sorry, I calculated again. It's 2.5 into 10 power minus 3.
And we can also write it as 0.025. Okay. So now what you need to do is, because the first one was HCl, ratio MgOH. Really? No. Yeah, okay. So HCl, for this HCl, the value that you got was 0.0125 and MgOH was 0.025. Now you're going to divide again with the lowest value. 0.125 was the lowest. So you're going to divide it on both sides. This is 1 and this is 2. 0.025 over 0.125 is 2. Okay. So once you get these answers, this is how you're going to balance the equation. HCl is 1 here, okay, and 2 is with MgOH whole twice, like this. All right.
Okay, we divide it with the lowest number.
Yes, exactly. And the answers that you're gonna get will be the coefficients of the equation. Again, this equation is not
Okay.
accurate because in an actual chemical equation, one should be with MgOH and two with HCl according to the balancing rules. But again, this is just an example question, and this is how you're getting the answer. I hope the concept is clear that to reduce
Yes.
stoichiometry, you need to figure out the moles first of all, and then you need to take the moles ratios and to figure out the balancing coefficients. Okay, this is all. This is how you use titrations for these balance for balancing. Okay, now moles and redox reactions. This is another topic. You must have studied redox reactions in your O-levels chemistry, electrolysis and redox, but we're gonna just touch redox here, not the electrolysis part. So I'm just gonna write down a few things here to revise these concepts for you. Number one, redox is basically reduction and oxidation, right? Chemical equation that has both the oxidation reduction. What is oxidation? Dua?
Oxidation is loss of electrons
Yes.
and
Yes. And reduction is gain of electrons.
gain of electron.
So, and obviously when electrons are lost, the oxidation state increases. So oxidation is increase in oxidation state. And reduction is decrease in oxidation state. Some common oxidation states. A natural element has an oxidation state of 0. You can just note these down. Group 1 metals have an oxidation state of positive 1. Group 2 metals have an oxidation state of positive 2. Group 3 metals have an oxidation state of positive 3. Transition elements have variable oxidation states. I mean, their oxidation states can change. Oxygen will always have an oxidation state of -2 except for H2O2. Oxygen in H2O2 will be -1. And hydrogen will always have an oxidation state of +1 except for metal hydride.
I'm sorry, which one will be -1?
Oxygen in H2O2 will be -1. And
Okay.
hydrogen and metal hydride will also be -1. Otherwise, oxygen is -2 and hydrogen is +1. These are some common oxidation states. You can figure out the unknown oxidation states with the help of these common oxidation states. All right. For example, if let's say you have a compound, Fe2O3, okay? So you know oxygen is -2. You're going to use this table first of all, okay? And let's say you're asked to find the oxidation state of iron here, Fe. It's a question mark. So what you're going to do is you'll look at this table and you'll see the values that you already know. Oxygen is always -2. So what we're going to do is we'll use X for Fe, X, but X will be ×2 because there's a 2 as a subscript for iron, plus oxygen is -2 times 3 is equal to 0 because it's a neutral compound. Okay. And a neutral compound is always equal to 0. Simple calculations, 2x minus 6 is equal to 0. 2x is equal to 6. X is equal to 3. So iron is +3 in this case. All right. Are you clear with how to figure out the unknown oxidation states?
Yes.
And let's say if there was a compound in form of an ion, not a neutral compound, for example, MnO4. MnO4 has a whole charge of -1. So this whole charge of -1 is basically applied onto this entire compound. And okay, so now in MnO4, you already know oxygen, right? Oxygen is -2. And you are used to figure, I
Can
mean,
you repeat this part, the oxygen 1, 2 into 3? Where did 2 come from?
2 from here, from the table. This
No, this, the Fe2O3.
this small 2 here.
Like x into 2, no, x into 2 plus 2 into 3.
If you
Where
focus on,
did 2 come from?
okay, so this first 2 is basically the subscript of Fe2O3. You are supposed to multiply that with
Okay.
the oxidation state. And the second -2, this -2 is the oxidation state of oxygen that we already know. It's in the table.
Won't we add -2 or just -2?
I mean, it's -2, sorry. This is -2.
Yes.
Okay,
Okay.
because this is why we're getting -6 here, no? Okay. So, and now if you look at this MnO4, MnO4 has a whole charge of -1. So what we're going to do here is, we already know what oxygen is. Oxygen is -2, okay? Mn is x, Mn को x रख लेते हैं. X plus oxygen is -2 times, this is 4, so we have to multiply this 4, okay? Is equal to, now we're not going to equate it to 0, but to -1 here. Why? Because the whole charge of this compound is -1. So x plus -2 -8 हो जाएगा. -8 is equal to -1. X is equal to -1 plus 8. X is equal to 7, +7. So the charge on Mn is +7. Is this clear? Are you clear with this?
Yes, I am.
Now I am giving you a few example questions to attempt as homework, just to figure out the unknown oxidation states. So for the first one, if you're given with, let's say, MgCl2, you need to figure out the oxidation state of Cl2. No, I'll just underline the compounds, okay? If, let's say, Cl2 is underlined, you need to tell the oxidation state of Cl2, okay? So in this question, you know Mg will always be +2. Why? Because it's in group 2. And in the table, we've written that group 2 metals are always +2. Group 1 is always +1. Group 3 is always +3, okay? So you also need to look at the table before you attempt these questions. Then NaOH. And for the NaOH, you're supposed to figure out the oxidation state of oxygen here. For the third one, you are given with Al2O3, and you're asked to find out the oxidation state of Al, aluminum. Fourth question, K2Cr2O7. You're supposed to find out the oxidation state of Cr2, chromium. And the fifth one is KMnO4, and you're asked to find the oxidation state of Mn here. All right. So all of these underlying elements, you're supposed to find their oxidation states. You can use this table. This table is very important, okay? All of these are neutral compounds.